All right, welcome everybody. It's October 10th, 2023. I'm your host here, Ross Platel for CivicTechYYC. Tonight we have in-flight data and AirMatrix for mapping urban wireless networks to open innovation. Before we get started, just a land acknowledgement here. CivicTechYYC is an organization that resides on the traditional territories of the peoples of the Treaty 7 region in southern Alberta, which includes the Blackfoot First Nation tribes of the Tsitsica, the Piikani, the Kainai, the Stoney Nakoda First Nations tribes, Chiniki, Bearspaw, and Wesley and Tsuut'ina First Nation. This is also homeland to the historic Northwest Métis and the Métis Nation of Alberta Region 3. CivicTech is a group that is involved in the use of technology for public good. We use data to address design challenges that citizens and governments are facing, help citizens and governments work together to use technology and data, pursue opportunities for greater citizen engagement and more effective services, as well as grow public engagement and enhance digital services in ways that are more inclusive, responsive, innovative, open, and citizen-centered. And with my little diagram here, you can see that we sit in the middle of all these various areas. We're a global movement and have expanded drastically over the last 15 years through organizations that support us like Code for All. In the US, there are cities like Chicago, Boston, New York City that have led the CivicTech movement. And I've also seen other organizations such as Code for Canada, US Digital Service, and 18F. There's CivicTech organizations in many locations across Canada, and all are listed on the Code for Canada website, including government agencies like the Canadian Digital Service. Launching CivicTech in Calgary, we were launched in 2017 by bringing together people that had an interest in improving their community by leveraging technology through the support of the City of Calgary and Rainforest Alberta, and it was a driving force to break down the barriers between sector silos and create a space for collaboration, addressing the challenges and opportunities of citizens and government. And the CivicTech community here just sits in between our technology industries and citizens and city, as well as entrepreneurs and scale-ups. Just looking at data in the social sector, the amount of data has been ever increasing, and organizations are trying to leverage the power of data-informed decision-making. Many lack the skills and resources to collect and understand and use that data to make better decisions, and data professionals with knowledge and skills want to become more engaged. And here at CivicTech, we promote volunteer projects and facilitate connections to make those tech for good projects happen. I've just got the charts on the side here for the explosion of data. Most recent chart I added has the data up into the projected amounts for 2024 and 2025 there. And I'd be interested to see what we actually see at the end, because I feel like there's more data growing ever faster than what that chart is actually projecting. Data-informed decision-making, we start with the data at the bottom of the pyramid and move up through information and knowledge and ultimately come to the pinnacle that is the wisdom from that data. Some of our major projects include the BudLib project, which is a library database management project, some of the blockchain experiments, and Volley, which is a volunteering app that Alice Lamb started here in Calgary. The civic user testing groups we're involved with are grassroots groups that facilitate better and more inclusive and accessible usability testing that engages residents in the creation of technology that's meant to serve them. The concept started in Chicago and has spread across other cities, including the Toronto Script program, and now with Inclusity here in Calgary. So with Inclusity Calgary, it's a team of technologists, designers, public employees, community organizers, entrepreneurs, policy analysts, and other engaged citizens that share a vision that Calgary can be more accessible for all. The mission is to plan, design, and run testing sessions that are inclusive and representative of a group of Calgarians to improve the usability of products, processes, and services for teams in the public, private, and nonprofit sectors. And we're proudly supported by the Calgary Foundation, and the other group that we're partnered with for it is Calgary UX. And just looking at some of the partner organizations and group that CivicTechYYC is involved with, there's Code for Canada, which is the national group, Calgary UX that I mentioned, Data for Good, which is our more data-focused parallel organization, Rainforest Alberta, that helped found us. There's also the YYC Data Society, Platform Calgary, and for immigrants, there's the Immigrant Techies Alberta group. And just here's our socials, so you can find us on Meetup. There's our website, Twitter, which I realize I have to say X, formerly Twitter now, because the name is changed, but I don't think the URL has just yet. Instagram and LinkedIn, and you can also find us on Facebook now as well. I'm gonna stop my screen share here and then hand it off to Chris. You've got your presentation ready to go there, I believe. Want to get your screen share up and started, and we can dive in.
Yeah, you bet. Thanks, Ross. Appreciate it. Hello, everyone. My name's Chris Healy, and I'm the president of In-FLIGHT Data. And we've got a presentation here to make to you today on a project that we did in the city of Calgary together with AirMatrix. And without further ado, so thank you again for having us here today to talk about our project. We wanted to go out and build off of some work that we had done last year around mapping urban signals, specifically as it relates to enabling and unlocking urban air mobility innovation in Canada and elsewhere. So a little bit about myself. So I'm the president of In-FLIGHT Data. We're an Indigenous technology company. Our focus is on drones, drone systems, drone training, service support, and artificial intelligence using drones. We've been in business since 2014. We're located just south of Calgary in Okotoks. I myself am a fifth generation Calgarian, and we're happy to be able to do this project. We also did it with Ian, and Ian's on the call today. So Ian.
Thanks, Chris. Thank you for being. Thank you for your time, everyone. Yeah, nice to meet you all. Yeah, I'm co-founder of AirMatrix, also head of mapping. So we build millimeter precise skyways in urban suburban areas to be able to create the next layer of digital infrastructure for drones to be able to operate and scale. I know a lot of that sounds like sci-fi, but we've conducted and mapped multiple cities within Canada and now heading over to the US as well to be able to create almost like roads in the sky. And this project's really about gathering the relevant data sets we needed for this sort of these sort of operations to scale. So yeah, I'm very, very excited to be here and happy to demonstrate what these data sets look like. And we've actually got our first prototype up and running. So super excited to demo you that. Yeah, Chris, you can take it back.
Awesome, thanks, Ian. We'll call on you a little bit later just to show a little bit of a demo of what you got prepared there. So thank you very much. So a little bit about the project itself. So this project's been around for a couple of years. This is the second phase that we had done. And back in 2021, we had partnered with AirMatrix as part of the remote traffic management trials underneath the Transport Canada Remote Traffic Management Action Committee. So Transport Canada and NAV Canada, along with the NRC and ISED and some other organizations, got their heads together and said, look, we know that flying drones, flying taxi drones, drone deliveries, we know that's going to be a real thing in the future. We know that's where ICAO, the International Civil Aviation Organization with the United Nations, that's where they are looking to go, and they're bringing in regulation around drones. So we really need to get our heads together and start some trial projects so that we can start to figure out how we're going to build these highways in the sky. And so we partnered with AirMatrix back in 2021 on some project feasibility, and then we got together with them back in spring of 2022, where we started to map out exactly what we wanted to do. So last year we did a phase one of the project. We tried a couple different technology types, a couple different aircraft types. We really kind of found our niche in how we wanted to get the project done. We also wanted to make sure that we were following in line with the Transport Canada regulations, and so we brought in some detect and avoid, some ground-based radar that we're able to use to blanket the entire city of Calgary to let us know where objects might be in the sky as we were flying our drones. And then we went out and we did it. And in the summer of 2022, we mapped about 50 kilometers of the city of Calgary above city of Calgary roads without an SFOC, because that's was legal under the current regulations. And we didn't have any safety issues, and there were no incidents. And we actually had a couple of citizens come up to us and ask us what we were up to, and we explained to them what we were doing. And they thought that the use of the technology, drone technology, was amazing for this particular use case. And so we bundled that all up with a bow, and we said, look, we'd love to do phase two of this project, but we need to map some more. And we went back to the City of Calgary's Living Labs program, and we said, look, we've got an even bigger project that we'd like to do, and we'd like to increase the scope from going just over city roads to entire neighborhoods. We wanted to fly over people's sheds and gardens and fences and backyard laneways and map all of the urban signals that existed everywhere in those areas. And so we went through a really intensive planning process, again, with Transport Canada and the City of Calgary, and we were approved to fly through what's called an SFOC, or a Special Flight Operating Certificate, that we got from Transport Canada, that gave us permission to fly to almost 1,000 feet above the City of Calgary. And we mapped a very, very high density of information above where cell phone towers currently exist, up until where drones won't be able to fly, which is around 1,000 feet. And so we had a hypothesis, and that was that we could, using drone technology and using specialized payloads and some specialized software and some specialized hardware, and all of our knowledge and skills and expertise all tied up together, our hypothesis was that we could accurately locate and quantify cellular C2 link quality above an urban center. That's a really big deal because it doesn't exist today. We wanted to be able to do it in a resolution of data that was going to be useful for future purposes, specifically navigation, that we had a baseline to compare to. And we wanted to make sure that we were doing it up to about 1,000 feet above the ground, so that we were really mimicking a real world use case of where flying cars and flying taxis and drone logistics would actually exist in the future. So here's a couple of pictures of what we thought it might look like. What you're seeing on the left is a picture of a visualization of the radio waves, or what was thought to be radio waves, in the city of Chicago. And as you can see, the black kind of void on the left-hand side is Lake Michigan. And what's being visualized is the cellular signals that were emanating from the different towers in those sectors within Chicago. And there's some credits along the bottom of where this visualization technology came from. But this visualization is quite old now. It's about 10 years old. And of course, we can't see radio waves. And so we have to invent colors and spectrum so that we can invent or sort of understand what the radio waves are, where they are, how strong they are, and what that means to our world. On the left-hand side, you're seeing a similar representation using the similar methodology, but again, on top inside New York City. And in New York City, there's lots of high rises, and so there's lots of cell phone coverage, because you can get those cell phone towers much, much higher up in the ground than you can in, say, suburban Chicago. So this is what we thought it might look like. And again, here's another slide. Again, on the left-hand side, you're seeing what a visualization of the cellular signals might look like at the Herbert Hoover Building in Washington, D.C. And on the right-hand side, you're seeing what it would look like in the Hollywood Hills, where you've got three different channels irradiating in all those different directions. And so we wanted to sort of prove this hypothesis. Is that kind of what it looks like? And so we went through the effort in the city of Calgary to go fly over top of that road. And what we found was what you're seeing in front of us right now, where we were able to map signal levels, and those the signal level on the right-hand side there corresponds to an ASTM standard that's being used in the drone industry. And we said, based on this information, we'd love to be able to cut through the information in 3 dimensions, because drones don't necessarily fly at one altitude all the time, and they don't necessarily fly over straight roads all of the time. And so what did the signals look like in between those roads? And so that's what we set out to do in phase 2, was to color in those lines. Now, this is really important, because pretty soon you're going to be able to jump into a flying taxi and go to Banff. That's a real thing. And on the left-hand side, what you're seeing is an image of one of those flying taxis by a leading company in the industry, the urban air mobility industry, Joby Aviation. That's their current demonstrator vehicle. And on the left-hand side, you're seeing the demonstrator vehicle of another, what's called a VTOL, or vertical takeoff and landing company, aerial urban mobility company. And these are 2 ideas, and there's many, many others that exist in the market today. But by 2028, the FAA in the United States is going to allow these flying taxis to happen. And in some small markets, they already are. Dallas, San Francisco, these are already happening today in small sort of proof of concept type tests. But in 2028, the FAA is going to unleash it to the marketplace. They've already started creating some standards in this space. And the challenge is that in Canada, we have a Canadian Aviation Regulation, or a CAR, that states that all pilots must be familiar with all of the information that is relevant to the intended flight. And today, drones are flown using command and control modules, ground control systems. Sometimes they're radio, sometimes they're done over cellular networks. And in cities, they're likely going to be done over cellular networks. And until now, no government and no telecommunications provider could really tell you what the cellular fabric looked like above those those cell towers, because they've never been quantified or validated until now. And that's what this project did, was quantified and validated those cell signals. So we went out to the city of Calgary, into the urban area, into the city's parks, into the city's alleyways, and we really tried to make use of all of the different pieces of infrastructure that the city of Calgary had available to us, because that was made available to us through the Living Labs program. Thank you very much to the city of Calgary for that. And what you're seeing here in these pictures is us launching our aircraft in some city parks, where we, on the left, you see we had set up a security perimeter in one of the parks to make sure that we weren't impacting any of the users of those parks while we were conducting these missions and operations. And you can also see some of the security perimeter in the middle picture there as well. And then on the left or on the right hand side, you're seeing a really kind of zoomed in close up shot of the aircraft that we use. And on board that aircraft, we carried a very specialized payload that was able to not only measure different cellular and radio data, but also very accurately measure its position and some other location information that we were able to use to create this map of this data. Because we were flying above 400 feet, that's where all the other manned aircraft fly. And so we had to make sure that we were coordinating with other crewed aircraft providers, such as STARS Air Ambulance. And in fact, we did actually have an event with STARS where we had to co-manage the airspace together to ensure that we were being safe. We had to coordinate with the Calgary Police Service, because Hawk's helicopter is flying around the city of Calgary, and they were very interested in what we were up to. And so we had to make sure that we were following the rules of the sky, coordinating with all the different users, and making sure that we were operating safely. What you're seeing in the center is a setup of one of our ground control stations. You can see we had a really tall radio mast so that we could broadcast our radio waves well over 4 kilometers from where the pilot was based. And what you're seeing on the right-hand side is a picture of the aircraft with the part of its payload in its bay. And that's the aircraft that flew over the city of Calgary for over 660 kilometers. Oh. Now, in conclusion, and I'll show you what the data looks like here in a moment, but the US has already created vertiport standards, and these are areas that are specifically designated for these urban air mobility vertical takeoff and landing aircraft. There are published standards. You can go onto the internet today and see them. And they're designed both for airport environments as well as urban environments. And the picture that you see on the left is a sort of a blend of an urban environment or a downtown type vertiport slashed with what it might also look like in an airport. And these standards are what's going to be used as the kind of the first foray into urban air mobility, and are being used in places like Dallas and San Francisco and San Diego. So here's a short little video, courtesy of AirMatrix, of what we now think the data fabric looks like over the top of an urban area. So I'll just quickly start this up.
Introducing Ether by AirMatrix, a dynamic tool designed to optimize navigation in airspace for telecom companies, BlueVloss drone operators, and other airspace users. To illustrate, let's dive into a demo in Calgary. We start by selecting Calgary from our extensive city database. Next, we specify our area within Calgary and set the altitude. We then generate a 3D prediction of cellular values, such as RSRQ and RSRP. Ether makes this complex data accessible and reliable. Underpinning Ether is the sophisticated AI and machine learning technology from Palantir, enabling dependable predictions. Finally, we visualize Calgary's airspace in 3D, providing insights into the unique characteristics of the selected area to ensure safer, more effective navigation.
Awesome. So that's just a short little teaser for what Ian's going to show us here in a moment. This is not what we think like. This is, a small little snippet for the city of Calgary, but here's what it might look like over the city of Toronto. Again, all of this data was collected in the city of Calgary and fed into AirMatrix's process, and here's a visualization of what it looks like at a particular altitude, and I guess that's a really important caveat. Depending on what altitude you're trying to fly at, will give you a slightly different result. And here's what we now think it looks like around downtown Calgary. And so as you can see with all the 5G networks that are in downtown Calgary and around Stampede Park, we're getting some really good connectivity data. This would heavily support a use case for urban air mobility. Whereas if we started to get out past south of 17th Avenue or out sort of east into Inglewood, those areas look like they could use some support in terms of signal strength out there. So that's now what we think it looks like. And so now I'll turn it over to Ian for a short little demo.
Yeah, no, I think we made the video a couple of weeks ago. There's obviously more features and more things that we're adding on top of this. I'm just gonna share my screen to show you guys the real, like the platform live in action. So again, this is, private platform that we made. We haven't made this public yet. We're still testing it out with, a few group of users, opening it up to drone operators like Chris that are, considering flying beyond visual line of sight to understand how connectivity looks like. So I'm just going to share my screen. Is able to see my screen?
Yeah, it looks good.
Awesome. So we can see, the city of Calgary. We actually added 3D buildings in here as well, in this week. So for example, we want to generate a prediction. We can actually do it in 3 dimensions. So like Chris mentioned, we can select an area. We draw it out. For example, like let's draw downtown Calgary. We can, obviously like longer areas take longer times for prediction, and we can select an altitude. So this is in meters. So, drone flights are, the highest that drone operations are flying right now. It's at around 121, 400 feet. It's 120 meter. You can go a little bit lower, close to the ground, and just predict around 60 meters. Select our carrier and generate a prediction. And we can see that this generates a, sort of obviously like cool colors, but as you can see, green meaning RSRP and RSRQ signal quality and signal strength. Values can be determined, which is super critical, like Chris mentioned, for understanding what your connectivity looks like. So you can see this area, there's some lower connectivity in this area. We can create almost just for ease of visualization, we can go and, sort of like make it 3D right here. It makes it look super cool. And yeah, we can move around and see and predict different areas. See, if we were to do a drone flight before this platform, there was nothing that was available that would allow drone pilots to understand connectivity across their operation beyond their line of sight. And this is really, one of the first sort of data sets that we're providing to our pilots to be able to predict this and to understand what connectivity looks like. Again, as more and more altitudes are unlocked for drone operators in urban aerial mobility, for air taxis to fly in, this sort of data is critical. We see obviously our job and what we've done with in-flight data, this partnership to be able to scale this with different cities and to be able to collect this. Yes, these models can be used for different cities, all over Canada at the moment. But the models are only as good as the data that's fed in. We flew a lot of flights, so we've got hundreds of kilometers of flight data, which we fed into our models to make them really accurate. But for areas, for example, more rural and more remote areas, for us to predict there, obviously we could collect more data and make that prediction better. So would love to take questions and demonstrate. I guess I'll flip it back to you, Chris, if you wanted to chat about something here or want me to show something else.
Yeah, awesome. Thanks, Ian. Just since you're in Ether right now, what if you were to check 200 meters?
200 meters, yeah, we could predict that as well. I have to reload. Obviously, this is a prototype platform. This is first time we're publicly actually showing this, so it's gonna end up on YouTube, so that's quite interesting. Yeah, let's do a larger prediction for 200 meters, like the carrier. Let's select a different area as well, like a lot wider area, so we could get more of the coverage for the Stampede Park. I'm not from Calgary, I'm from Toronto, so I'm not really aware of a lot of the areas, but um,
Well, you got Stampede Park there.
so this is obviously a larger area, it's taking a longer time to predict. Um, but again, behind this is all artificial intelligence, machine learning. We've used this to create these models. Let's see. It's still predicting something. That's what I love about live demos. Something are always that goes a little bit wrong.
Just while it's building, could I ask a question?
Yes, of course.
Yeah.
I'm curious, we're talking about the cell signals and the strength. Under VFR rules, visual flight rules, it's sort of an operator seen be seen. Is the communication network strength and dispersion specifically so that the UAV operator can have direct communication with their unit?
So in the drone world, see and be seen is VFR is it's not quite the same thing, because the pilot has to be able to see the aircraft. When the pilot can't see the aircraft, that's beyond visual line of sight. The purpose of the being able to predict the strength of the cellular signal that you're flying through is to be able to provide yourself a sense or a certainty that your aircraft will always be able to maintain connectivity with your ground control station so that your aircraft doesn't fall out of the sky. And so if that means if you're plotting to fly from South Calgary to go up McLeod Trail all the way downtown and then make a beeline to the airport, you're going to want to make sure you're not flying through any of those red areas that you just saw pop up on the screen, because that might mean that you could lose contact with your aircraft and crazy things happen, right? Flyaways or falls out of the sky. And especially if you've got flying taxis with people on board, you can't have that happen. So that's the purpose of this, is to have a technical tool that operators like myself and regulators and telcos can use to operate safely in the future.
Hate the distinction. Yeah, I did a compound question there and I should not have. Thank you.
Did I answer your question?
Yes. Yeah. So it's basically to maintain, make sure you have communication, as you said, with the base station. That's perfect.
Now, there are a lot of other things that could come through this. I mean, obviously, if you're connected to an LTE or a 5G or some future 6G network, there are other things that benefits that could be had by maintaining good quality connections, good signal connections, and one of them could be communications relays and other sorts of things. But it all starts with the basics.
Right. I think I predicted a bigger altitude. I think we got 120 meters. Something is a little bit buggy, I think, on the back end, but I think we've got safe to say that, it's doing its job, I think, predicting well for different altitudes. And of course, like larger areas take longer to predict. So we've got a lot of computing power in the back end. Yeah, we could try a specific area, play around with this, but we'll be making this tool public, I think, at some point, which obviously the general public can have access to it as well. But we've again opened it up to a few beta users right now to be able to improve it and work on this. So
I'd like to ask, just because now we've got this prediction here and you can kind of see the red area next to Stampede Park and around Inglewood. The rest of the downtown is relatively good other than a few red spots. Well, can you understand, even when doing this prediction, what might be causing the red in that area and what sorts of things could be done to improve those regions and the connectivity that's there?
So I have some thoughts, and first off, I'll say I'm not a telco or a network engineer. I'm not it's not my specialty. But towers are built and antennas are constructed in such a way that they are meant to service their customers, and their customers today are on the ground, and their customers are not in the air, generally speaking. And so, this prediction in the air is showing what it would be right now at 400 feet. And there are no towers downtown Calgary at 400 feet. And all the towers that are in downtown Calgary, again, are pointed down at the ground. This particular picture, anecdotally speaking, does ring true. I have some friends that live in that particular area of Calgary, and they're always complaining that they get really lousy cell service in that area. And so there could be a number of things, all of which would relate to sort of network engineer type stuff. As a drone operator, we went and collected the data, and the artificial intelligence is predicting based off of that data. And so, I could speak to it anecdotally, but without being an engineer, and speaking to, the infrastructure that might be located in that particular area, or the topology that's in that particular area, because those things will all affect network strengths as well. That's kind of where I would point at. Ian, any thoughts?
I think you summarized it pretty well. My background's not in RF as well. We deal mostly with again, drone technology, drone integrations, AI, ML. But certainly we've worked with telcos to be able to understand more locally as well. So we've flown around specifically for use cases, inspecting cell towers and signal quality and strength around the cell tower as well. But those are more local projects. But at this scale, we haven't really, it's the first project of its kind really where we did it at such a large area and being able to, create a model out of this. So that's just my thoughts on that.
Cool. Thank you both.
Thank you very much. Appreciate the opportunity to come in and chat about this really interesting project. What really gets me excited about this project is, I was born and raised in this part of the world, and way back when they were building the national railway, people had to come before the rails came through, and they had to survey the land and figure out the best route to put all the things, and how are they going to make this big rail project happen, because they knew this rail project was important. This infrastructure project was important to the future of Canada. And we really liken what we've done in this project to that, is that we've gone ahead of the urban air mobility companies, ahead of the regulators, ahead of the telcos, ahead of all of the other infrastructure folks, and said, we're able to collect this data that exists in a really, really hard place to get to, because in the city of Calgary, regular planes generally can't fly below 1,000, but drones can't fly above 400. So you've got this no man's land between 400 feet and 1,000, where no one understands what exists in terms of RF in that space. And so to be able to collect that data and produce it in such a way that becomes an enabler to the innovation of urban air mobility is really exciting for us. So thank you for the opportunity to get out and share the story of what we've done, and really appreciate the opportunity. Thank you.
Yeah, I think from our perspective as well, I also want to take some time to thank City of Calgary. When we started, we're a startup company. We started out of Toronto. We were, our job really, like our mission is to create the next layer of digital infrastructure. That's literally our company mission. And the support that we received from Calgary, and to be able to test and do a lot of this. I know Chris had to do it, In-FLIGHT Data really had to do a lot of hard work to be able to coordinate, approvals, and coordinate permissions to be able to fly at these altitudes. It's not an easy job. It took sometimes months of approvals. But really like to appreciate all the effort from the city as well. To get this far where now we're not just able to use this data for Calgary, but we're other cities will be able to benefit from this. And these learnings are, again, we're taking this back with Transport Canada. We're going to be doing some work with the FAA as well. And so it's a really exciting time. And when those air taxis are there and those drone deliveries are happening, for sure, this projects like these and research and findings like this will enable that future to really come true. So thank you very much.
Yeah, thank you both. Go ahead, Brent. You got a question there.
Yeah. A non-current private pilot, so kind of know some of what happens. I'm kind of curious. Is Transport, you've mentioned 2028 for the FAA. I'm kind of curious, has Transport Canada given you any indications of what the next phases might happen in Canada or might be available for you in Calgary?
These are the next phases, right? There are urban trials that are looking to happen for the next round of trials that come up from the Remote Traffic Management Action Committee. So we are looking to have some additional trials this year. I know that there's a call for trials planned to go out in the fall of this year. So we're in the fall now. So anytime now that the call for trials will go out. And then based on that information, Transport Canada will be incorporating that information into their new set of regulations. And so currently in Canada, Transport Canada has a set of proposed new regulations set to come into effect in sometime in 2024, 2025, which will unlock some of the aspects of what we talked about today. And so you'll see a sort of a stepped approach from Transport and Nav Canada together to move in the direction of urban air mobility. There are some pockets that are happening now. There's a pocket of urban air mobility happening in Vancouver. The Urban Air Mobility Consortium is sort of leading the pack there. And there is also a subgroup that Transport Canada has created around urban air mobility specifically to incorporate the stakeholders in urban air mobility from across Canada. So not just the operators like myself, but the manufacturers, the cities, the First Nations, different groups that will all be affected by urban air mobility to start having that conversation. We're certainly going to be behind the United States. That's likely going to happen, but we won't be too far behind them.
Okay. And in private pilots, Mango, you'd have a transponder in a Cessna or a Piper. Is that something that's also sort of overlaid onto the drones then once they get into that, that 400 feet plus?
So as far as Transport Canada is concerned, and again, I'm not from Transport Canada. I'm not an inspector, right. but I do work with them from time to time, and I can tell you that from a Transport Canada perspective, these are all aircraft. Period. Full stop. So they have to be able to operate in the same airspace as all the other type of aircraft, and if that means that they have to have transponders, if they have to have all the different safety equipment that would be on manned aircraft, it will be very likely that they will all be mandated to have all that equipment, especially to fly in controlled airspace.
Okay, cool. And I know in like intercity, you've got airways, right? So different altitudes, different directions, and then you've got your mandated airways. Do you see something, and this is hypothesis, I realize you're not creating the maps for the future, but would something similar possibly happen, at least in initial phases for in-city?
In some of the discussions that I've had and some of the envisionings that the groups that I've been around in this space, it's starting to look a lot like what you see in Star Wars or what's that movie with Bruce Willis in the future?
Oh, you mean like Fifth Element? Was that one?
Fifth Element. Thank you.
Yeah.
So where you've got, laneways in the sky, one group of aircraft traveling in one direction, all in a line, they're all separated by a system to keep them safe, and another one at a slightly lower altitude, and then break apart from there. The future has yet to be written, for sure, but that's where this type of work starts to create standards, and those standards then turn into rules, and that's how highways and byways were, roads were created, and so it's going to be very similar to that.
Perfect. Thanks for your indulgence.
Yeah. And you've got a much more kind of global world view of this. What are you seeing in your the world?
Yeah, so essentially, that whole domain, it's really unmanned traffic management. So it's similar to ATM, but UTM is really, that space. And we're actually the first Canadian company to get authorized by the FAA to provide UTM authorization services to drone pilots across the US. And so, it's a program under the FAA. It's called LANCE. That's sort of like the first step towards, shared airspace and collaboration within multiple stakeholders, whether it's airports, obviously because there's critical aircraft flying near airports, and then moving more on towards cities. There's more concepts like Chris mentioned, like use space is a concept that's being used in Europe. There's other standards and bodies across the world really that are pushing ahead for more shared operations, for more data sharing between operations. We AirMatrix were sitting on a bunch of these committees across the globe really to see where the standards are headed and where we play what role we play within that. So a lot of our work has been around collecting these hard to get data sets, right? If we are to have multiple drones operating, if these roads are not accurate or precise, as an example, GPS errors, EMI issues, RF, these things can really cause huge problems. There was a drone flight that happened in Toronto a few years ago, and before this project had multiple health bodies that were responsible to bring it together. There's a lot of buzz around it, and the moment they started flying their drone, about 10 seconds into the flight, it crashes into a pole of a building, and the whole project was delayed another maybe 12 to, luckily no one was injured, but maybe 12 to 18 months that project was delayed. And so this was one of the, this is again early on, people didn't understand these data sets. Luckily for us, we're able to work with cities, and we're able to work with partners like in-flight to be able to get this data. But yeah, I think it's necessary for safety in the airspace, and more users as we see happening. We see drone flights happening across the U.S. Really, it's scaled over the last year. Hundreds of maybe thousands of drone flights now happening. Super exciting. I could talk about it for days, but that's sort of like my understanding and our learnings that have been there.
Well, there's an interesting work that's being done in the UK, I believe, where they're flying drone flights for organ donations and health blood tests and stuff like that, where it used to be ferry only to those islands. And so the drone's able to do it direct point to point within minutes or tens of minutes. Is it easier to do it outside urban then? But then you don't have the cellular networks that you guys are talking about, right?
Yeah, it's. I think Chris, you can talk about the operational challenges. Chris has done wildfire fighting and all sorts of really exciting use cases. So yeah, we can answer that.
Yeah, as soon as you get about 2 kilometers outside of a major highway or road in the country of Canada, you lose cell signal, and at that point you're limited in your communications options. You're looking at RF, or you're looking at satellite, which is expensive, or something local, and then you connect to the network after the fact. And so, there's, with the Remote Traffic Management Action Committee that Transport Canada has put together, it's not just looking at cellular communication technologies. There's about 15 different types of communications technologies that are being investigated as all working together as part of an ecosystem of communication technologies, so that we're not reliant on any one type of particular technology, because Canada is a very diverse area. LTE is only going to get you so far, and so if you want to fly from here to Banff, and you go anywhere outside of the Trans-Canada Highway, you're likely going to encounter something that's not going to be an LTE signal. And so how are you going to safely negotiate that? So there's lots of work that needs to be done to ensure that as the use cases build and grow and develop, not just urban, but transitioning into suburban and more rural type areas. If I wanted to have a delivery to go from Calgary to Strathmore today, what sorts of challenges would I encounter, again, from a communications perspective? Those are all questions that still have yet to be answered. So,
Perfect. Thanks.
sorry, the other component of that, and this with drones, and this is also critically important, is it's one thing to just say I can fly a drone from here to Strathmore, which is technically very possible. But by doing that, and not having some sort of sense of the airspace that I'm around and the other stakeholders that are in that airspace, it's very risky and very dangerous. And so, along with just flying your drone from point A to point B beyond line of sight, it comes along detect and avoid. And so, there's lots of other technologies that are being incorporated along with the communications technologies around, whether it's radar, whether it's reusing television signal waves, whether it's using some sort of inter aircraft communications technologies like an ACAS or a TCAS, or transponders, or a combination thereof. These are all going to come into play together before we're going to be able to allow to flying taxis around.
I know Brent mentioned the medical side of things, and I feel like we're probably at the sense that like doing this with humans by and large across the board isn't going to happen right away. What other sorts of technologies and deliveries do you see kind of leading the way in that path, either that are here now or coming in the near future?
The medical one is happening right now in Germany, in Hamburg. There is a small little group of drone innovation companies that have gotten together and created their own BVLOS network between the different hospitals in Hamburg. And so there are drone deliveries of organs and blood that are happening in the city of Hamburg every day, 5, 6, 7 times a day are happening there in that little innovation network. That's happening there, and there's no reason why that can't happen elsewhere. I guess another good example would be Zipline and the work that they're doing in Africa around getting medical supplies and organ and surgery supplies out into the fields would be another good example of that as well. Zipline's coming to the United States, so you're going to see Zipline doing its Zipline thing in the U.S. pretty soon, and it makes a great case for here in Canada as well. We've got a lot of communities in northern Canada that are very detached from each other, especially when the winter comes. And so being able to use drones to not only get goods and potentially services, but things, basic things like mail to these remote communities, groceries, are really important. And these types of technologies, mapping the signals in the sky to be able to get your good or service from point A to point B safely is important.
If I may, Chris, just to that point, most people think of drones being very tiny, but a dirigible could be a drone, right? A large one with a heavier payload capacity, which could carry the mail or goods. Is that fair to say?
Yeah, I mean, there's examples of aircraft today in the UK, for example. There's one particular aircraft that's doing Royal UK mail deliveries to the far islands around the Scottish Isles. And if I'm not, correct me if I'm wrong, but I also believe it's the same aircraft that has also landed on a UK aircraft carrier. So these are not small, little, tiny aircraft. They carry, 100 plus kilos of cargo, of whatever you want to put in it, and they become trucks. And you just fly these trucks from point A to point B with the cargo that you need onto them. Yeah.
With those type of deliveries and that kind of size, does weather become also a major factor then that you need to consider with those types of flights? Or are these vehicles now getting quite resilient for different weather conditions? I'm just thinking of when we have crazy wind and hail and snowstorms that kind of come up here in Calgary, which we're known for.
Wind in Calgary? I don't know what you're talking about. For sure. So weather is always going to be your greatest risk when you're flying any type of aircraft, whether you're flying a 747, you're flying an Antonov 225, whether you're flying a small little Mavic drone, weather is going to be your biggest risk. It's what you're facing every day. And so, the challenges do become a bit bigger and have different challenges depending on the size of your aircraft as well. So yes, weather is always a consideration, not just in terms of the performance of your aircraft, but also, in the theme of tonight's particular discussion, weather can affect your communications. And so, weather needs to be taken into account there as well.
I'm kind of just extrapolating long term from that then. Would there be then a need for us to have better weather sensing technology built in the city? For example, I have a weather app now and I can pull it up and I can see where there's a lot of weather stations. But there's actually no weather stations on my weather app that are right in the downtown core to be able to provide that information. And we're talking about cellular systems and connectivity. I'm imagining then there probably would be a benefit to having a weather station built into perhaps every cell tower to be able to kind of give you a sense of what that signal looks like on that tower to help inform and provide more live data and information for operations like this.
That would be a great idea. I mean, the democratization of weather would be fantastic. I know I have a colleague of mine, Don Birchhoff. He's the owner of a company called True Weather Solutions in the States. And this guy is amazing. I can't tell you how awesome this guy is. He knows more than anyone I know about weather, and I won't toot his horn too much, but he's pretty smart when it comes to weather. And he's got True Weather Solutions, which specializes in micro weather predictions, like at the 100 foot by 100 foot resolution level. And he'll be the first person to tell you that we don't have enough weather sensors out there. That weather is still an unknown. That it's more of an art than a science type stuff. We know some stuff. There's lots of stuff we still don't know, and more sensors the better. But sensors are expensive, so anyone out there that's working on miniaturizing weather sensor technology, that's a pretty good market.
Okay, so we got some pretty good potential markets and other areas for people to look into to bring improvements. I love how it's just a combination of a bunch of different technologies coming together to be able to really show this proof of concept and utilize it, but there's so much potential for different companies and startups to come in and innovate in those spaces now.
You hit the nail on the head, and I think, this project sort of lived at the nexus of kind of robotic IoT, artificial intelligence, geomatics, geoprocessing, satellite technologies, image processing. Like there's so many different facets of these things that all sort of had to come together in a nice little way to zipper together to create a nice little project. And there's lots of improvements on each one of those that could be done all along the way to make a much more robust type system. And that's the type of work that AirMatrix and in-flight have been doing with Transport Canada, and that's the type of work that we would encourage. If there are other people out there that have very innovative type solutions in this space, by all means, come on out to the Transport Canada Remote Traffic Management Action Committee. I extend to you my invite. I am the chair. Come on in. Happy to have you, and share with us those technologies, because this is how we are going to grow this within our own borders. It is going to have to be a Canadian homegrown solution because we are so very different than other places, both topographically speaking and climate, from a climate perspective as well. And so bring those ideas down. We need them all.
Curious, you've mentioned all of the different technologies coming together. Often, say in robotics, there's safe state. And what would be some of the safe states? Like, what would be some of the safeties when I have enough energy, or if the weather gets bad, where would you go from a safe state kind of point of view? Would you have safe landing?
Don't fly.
Don't fly. Don't take off.
Don't fly.
But some things are unpredictable, right? So if something does happen, would you have safe landing spots, I guess, then throughout your flights?
Yeah, you have to. Like, for example, when we were flying this particular mission, we always had a safe spot. I'll use air quotes, but it was a designated landing area for when things went sideways and we had to get out of the air very quickly. And so we actually came pretty close to having to enact that to using that when we had the event with the STARS helicopter coming through. We're above 500, he's above 500, and we don't exactly know where they are. They don't exactly know where we are. And so we said, no, we have to come down, let them come through. Wait, talk on the radio, make sure everything's clear. We're aware of each other. Things are good, and then continue and resume. So, yeah.
Yeah, I know as you get into IFR rules and instrument flight rules, I recently took off from Toronto heading up to Sudbury. It ended up being fogged in when we got there. Wasn't when we took off. And so circled twice after doing two almost landings and took off to our alternate in Timmins. So, yeah, it's in the rules now, and I figured something similar would probably happen for UAV.
Unpredictable stuff does happen, but weather is not that unpredictable that you don't know that something big is coming within 1 hour of you flying. And so for that big stuff, as pilots, you are expected to plan around that. When those unpredictable things do happen, that's why you practice, that's why you train, that's why you have emergency procedures. And all of those are really important aspects under the new Transport Canada regulations that are coming through. Operators are going to be expected to have standard operating procedures. They are going to be expected to have company operations manuals and emergency response plans and safety management systems and all of the regular things that all of the other aircraft operators have had to have for dozens and dozens and dozens of years. Any other questions?
Yeah, I was going to say, we'll open it up to last chance for questions. I know we're reaching top of the hour here. I think we covered a lot of good ground. Thank you for all the great questions and conversation. I think that
was awesome. That was good conversation.
Yeah. Well, thank you everybody for coming out tonight, and thanks for those that are catching it on the recording. I'll have the links in the description for Chris and Ian's companies there, and for some additional information if you want to reach out to them. And Ian, please let me know when you're ready for making that public, because I feel like there's going to be people who are going to want to dive into that data, both to figure it out themselves, as well as for people who are going to be wanting to run drones and figuring out what it's like as the technology continues to evolve. And hope everybody has a great rest of your evening here in Calgary, or whatever time it is, whenever you're catching it on either the live or the recording here. Really appreciate it, everybody.
Thank
Thanks,
you.
everyone. It's been a
Thank you
pleasure.
very much.